the ESV, that is, if you knew the volume in the ventricles before they contract, and you knew the volume in the ventricles after they contract, the difference would be what? The volume ejected. And what is the two-letter term for the volume ejected every beat at rest? Stroke volume. And what's your textbook number here for resting human adult? I gave it to you already. 75 mil. Your textbook numbers for these others look like that. So in a resting adult, the volume in the ventricles before they contract is about 125 mils. The volume in the ventricles after they contract is about 50 mils. So what volume was ejected? 125 minus 50, about 75 mils. So did you eject everything? No, you can see that. What percentage of what was there did you eject? Just like calculating a grade. You ejected 75 out of 125, so you ejected 60%. That is called your ejection fraction. I know some of you have looked at it, some of you are probably looking at it as we speak. But guys, I really think you'll find this document I created for the Nursing 106 students very, very helpful. You know, here's what we're talking about right there. EDV minus ESV is stroke volume. There's your numbers. Here's your definition of EDV and ESV. I mentioned a minute ago, I said I don't test you over this in this class. You build on it and apply it in nursing school. And I know you're not all going to nursing school, but I just told you what Afterload was. If you didn't get it, there it is. Okay, so I think you'll really find this document to be very, very helpful in tying it all, tying it all together. And you'll notice that it even includes where we started our discussion of hemodynamics. Remember? So I'd encourage you to use this. All right, yeah.
Does having a higher ejection fraction, does that mean the person is more physically active?
Yes, it does. So just like, say, VO2 max. The higher your VO2 max, the more physically fit you are. The higher your ejection fraction, the more physically fit you are. All right, this can go away. And finally, make a little sense for you out of these words, where they come from. You'll recognize this. You may have already picked up on it yourself. But your blood pressure, systolic pressure over diastolic pressure, 120/80 for a textbook. That is your maximum pressure over your minimum pressure, and that would correspond to, and this part just makes sense, I think, pressure associated with contraction versus pressure associated with relaxation. Okay, so the heart is contracting, relaxing, contracting, relaxing, contracting, relaxing. We're measuring the pressure in the brachial artery. Well, wouldn't the pressure be at its maximum when the heart was contracting? And when the heart's relaxing, the pressure would be at its minimum. So, go through the translations there. Again, EDV, ends diastolic volume, volume after diastole, whatever, whatever, whatever. D, diastole, that's on the bottom, that goes with relaxation. After relaxation is before contraction. So, as long as you've got it photographed, Amy. I'm just picking on you, you know that. But as long as you've got it written down, I think it'll all make sense. Does it make sense? I think it's super cool stuff. But then cardiorespiratory physiology is one of my areas, so I would think it's super cool. What I don't like is that freaking integumentary system. Remember when I accidentally came in here ready to lecture on that? And I had to do it that afternoon at 1:30. Could you tell I hated it? Another one I find boring is the digestive system. Okay, let's make sure we know where we are. All right, structure of arteries and veins, that's simply that tunica externa, media interna. So let's put our little, let's actually write some notes here. So systemic versus pulmonary, you're good with that, right? Arteries and veins, let's say lab, lecture, and then what's the letter E? Coronary?
Coronary. Mm-hmm.
Say lecture.
Hepatic portal system.
Is that F?
Yeah.
Or did it change to numbers? You know, sometimes Bill Gates does that too.
Q now?
It's Q. Okay, so something like that. So let me get it written down and you guys are free to go. Where's the attendance?
Do you want to decide when our test is
Oh,
going to be?
yes. Crap. Wait, your question, sir.
I wanted to make sure you put a date on this.
Okay, Adina has the same issue.
This is all ones we don't talk about before gas has changed. Blood difference.
What about this? So this, the valve?
Exam will be March 30th.
Okay. Are you ready for spring break? Let's study. Dude, I have to study for my CNA exam. I have to study for my TASE test. Good. Your CNA stuff. Your CNA stuff talks about systolic and dystolic, so you should be good.
I mean, if you guys want...
No.
I mean, if you guys want... Oh, God. That's great.
I'm cool.
If you guys want to fly through the rest of this on the 16th and have the exam on the 18th, I don't care. But it's going to be super, super fast. It's like I told, well, her name's Chris Johnson. She's my dean. With regard to those hybrid courses that they, not hybrid courses, but the bi-semester classes, you know, you can take A&P 1 and the A bimester and A&P 2 and the B bimester now. I said, well, I can stand there and spit this shit, but are the students going to be able to assimilate it? In undergraduate school, we did a 10-week crash course in organic chemistry. Now, that's not the Chem 102 that some of you are familiar with. That's our chemistry 211 and 212, or UCCS would be like 311 and 312. So it's 2 full semesters, 9 full months. So we had a crash course where you could do all of that in 10 weeks. It was like 8 hours a day, 5 days a week. And I didn't do it, but I knew people that did, and you know, they said, well, they didn't learn a thing. They didn't learn a thing. How could you? Because you don't have time to go home and assimilate what you talked about for 8 hours that day. You know, what are you supposed to study? Anyway, so are we? I mean, I realize it's not ideal. I think it sucks for you to have to come back and have an exam this day. But you do anyway in 201. It's just life, you know. So this is the exam day, guys, okay? That's what we're going to do. All right.
Well, it'll give us a quick break to study everything.
Right?
Well, I mean, as a student, all the professors always told us that spring break was